student impact in ExploreHope STEM education outreach. The areas of research that we focused on were how can we help students gain confidence in the educational setting? How can innovative technology allow students to engage in STEM activities? And how can that have a positive impact on them? We chose to focus on these areas of study because with the gain in confidence and the positive impact of technology comes the addition of learning outcomes and interest in STEM. To establish best practices within Explore Hope academic outreach programs, we focused on increasing student STEM self-efficacy and increasing confidence in students' ability to engage in STEM activities. For our literature research, we focused on the key factors to increase interest. We focused on the key ways to increase confidence and self-efficacy, and also how hands-on experience enhances learning. We found that engagement leads to self-efficacy because using interactive technology in the classroom can create identity as scientists or engineers. Students are also able to engage directly in the NGSS science and engineering practices, which can also directly increase STEM identity and self-efficacy. This is important because it proves that allowing students to use technology has an effect on their self-efficacy in terms of STEM. Students who actually do science are able to engage in multiple learning modes such as language, visuals, and formatting to express ideas. This combination is impactful for all students, especially those traditionally underserved in the STEM fields. For students in underrepresented areas, this is very important. This shows the importance of all students actually engaging in STEM activities. We also found that students creating their own research questions and authentically collecting data inspires a sense of exploration and discovery, which tends to lower perceived barriers to participation in STEM activities. Allowing students to create their own questions allows them to be more interested and participate more in the activities. Providing students with real-world applications in their schoolwork also increases conceptual understanding for all students. This makes it easier for kids to understand how STEM connects to their lives. An explicit focus on stimulating incremental beliefs about STEM ability could also stimulate positive self-efficacy beliefs in the STEM field and subsequently increase students' intention to opt for a STEM career. Another great aspect that we found is the inclusion of the teachers. Teacher attitudes and their own self-efficacy is equally impactful on students' increases in self-efficacy. The teacher is just as important as the student. We also found the value of community engagement since the systematic nature of gender and racial slash ethnic barriers to STEM success pose challenges for any intervention that does not address these issues on school, work, and community levels. These are the best practices that we found. By using engaging technology, we can help build the STEM identity in students. Increased STEM career interest from growth in STEM self-efficacy. Allowing students to create their own research questions helps with STEM identity, and having teachers to be more knowledgeable in STEM subjects allows them to be more helpful and confident when working with the students. Within our camps from the summer of 2020, we saw an increase from 1.82% to 11.64% increase based on a simple growth model from 6 camps. For our future work, we hope to refine our camp activities to meet the best practices and to refine assessment practices to appropriately measure the impact of these practices. Special thanks to the Hope College professors Carrie Doomer and Susan Ipri Brown.